I love being outside, the fresh air, that oxygen, that healthy, beautiful, wonderful oxygen. Don't you love oxygen? Me too. But it's killing us. Today, Earth's atmosphere is only about 20% oxygen. Most of the air that we breathe is nitrogen, with a couple of other trace gases thrown in. But every last member of the kingdom Animalian needs that oxygen to survive because it's how we power our cells. When we breathe in, our blood takes oxygen out of the air through our lungs and carries it to our cells, where it's used in the process of cellular respiration, which is how we turn the food that we eat into the energy that our cells need to do their business. But oxygen wasn't always in the Earth's atmosphere. In fact, oxygen's probably been around for less than half of the Earth's illustrious career, about 2.2 billion years. And it's only been in the past 600 million years that the atmosphere has had enough oxygen to support animal life. So the very first living things on Earth from which all organisms, including us, descended, didn't need oxygen. Which means that we have to deal with something that our most ancient ancestors didn't: oxygen's dangerous side. Maybe you're familiar with rust, or that brown color your apple turds after you slice it. That is oxygen reacting with the chemicals in the exposed metal or apple flesh and breaking them down through a process called oxidation. See, oxygen is a needy little element. It's one of those elements that follows the octet rule. It wants to have 8 electrons in its outermost shell, but each atom of oxygen has only 6. And since it needs 2 more to feel complete, it really likes combining with electron-donating atoms, like hydrogen when it gets the chance. And that tendency usually serves us well. Oxygen-hydrogen bonding is exactly what allows us to turn sugar into energy during respiration. But sometimes scientists think about 2% of the time oxygen comes out of the process not totally satisfied. So instead of being its normal, mellow, and stable self, it becomes a totally rogue character called a free radical. This thing will bond with practically anything that moves, if you hear what I'm saying. It'll try to pair up with the fats in your cell membranes, or the proteins in your red blood cells, even your DNA, and when it does this, the free radical changes the chemical structure of those molecules, sometimes damaging them. When a protein on a red blood cell is oxidized by a free radical, for example, the protein changes shape and notifies the immune system to take it down in a kind of mercy killing. When cell membranes oxidize, they can become less permeable, and the oxidation of DNA has been known to cause mutations that can lead to some kinds of cancer. Basically, oxygen rusts you out from the inside. This constant cellular wear and tear from free radicals is called oxidative stress, and some scientists think that it's an important factor in aging. Free radicals aren't all bad though. Our white blood cells actually use them to kill pathogens, and a growing body of evidence shows that free radicals are involved in the signaling between cells. So while our bodies make the best of the situation, they also try to keep free radical damage to a minimum. That's why we've evolved ways to combat oxidative stress by using antioxidants, or molecules that inhibit oxidation. A lot of foods contain antioxidants like vitamin E and C and beta-carotene, which help protect our body from free radicals by neutralizing them, giving them something to bond to so that they won't have to rip your cells apart. Oxygen. You can't live with it. Actually, you can live with it. You have to live with it. You'll do a pretty good job living with it. I would not suggest trying to live without it.